Okay, just wanted to show you a little bit about working in R and specifically how the code works for this little example. If you have questions about just like getting R installed and real basics of R, we got another video up on the module, so be sure to watch that if you need more information on it. This is going to really just be background on the specific code in case you're curious. You don't need to obsess over this if you're not that interested in coding. But if you want to know why it works, here's a little explanation. First things first, as a reminder, if you're new to R, you might need to install the packages. So ggplot2 we're using to make charts. And then we'll also have this outbreaks package. So the outbreaks package just has a ton of publicly available data sets on outbreaks, infectious disease problems. So that's where I thought it'd be a good example for this group just to get started. And we're going to use one that's about COVID in the UK. I already have them installed, so I'm not going to run those, but I'm going to run my library statements here. So in case you're new to R, the library statement just says, all right, I've already downloaded the package. I have the software on my machine, but I want to bring it up into like my computer's working memory. So if we select it and click run in the top right section here, or we type Control Enter, that's going to bring it into the computer's working memory so we know how to use it. And so this here, if we just ran this code here, this COVID-19 England NHS calls 2020, this is just what the data are called in the outbreaks package. And so if we run that, we get all this information. It's way more information than we really are interested in. That's one of the challenges when you're working with publicly available data. People give you like way too much information. That's really why I wrote this code, to try to summarize it down so you can really just focus on making charts. I'm going to save this data. I'm going to call it dat because I'm lazy with my names. And so this is just going to save as an object. So we're saying dat is equal to create an object that is the data set. And if I select dat now, I can edit it. It's now my object in my local machine. We can see it here in the top right in the global environment. And so now this is like way too much information about every single person who had a positive COVID infection in 2020 in, whatever areas of the UK. I'd really like to summarize this. Notice in this date column, so looking at the console in the lower left, there's a variable here that says date. It's got every single date starting on March 18th, it looks like, going through the year of 2020. That is too much information. I do not need information on every single COVID case. I really just want to know how many COVID cases there were for each day in the data set. So I'm going to say, all right, I want to make a new variable. So I'm going to go into the object called dat. So this is our data object. Specifically, I'm going to use the $sign. The $sign says pick out a variable. So in the object called dat, pick out a variable using the $sign called date. That's going to give me just all of the dates. So we can scroll through here. If we run that, all the individual dates, there's like a ton of them in here, way more than can fit on my screen. And what I'm going to do is I'm going to run this unique function. So unique and then open parenthesis, then dat date. So what's going to do is it's going to say, all right, I don't need every single itemized COVID infection. I just want to know what the trend is like. So give me all of the unique dates. If we run this little bit of code, it's going to have a unique value for each and every date starting on March 18th. And it just keeps going up and up and up. And that's the whole point. If that's what I'm interested in, how many COVID infections were there over time, then I can use this function to help figure that one out. So I'm going to create a new object called days. And so days is equal to all of the unique dates. I'm going to save that. So I've got the information I need. Notice that we got it up here in the environment now. This is days with a capital D. So now I've got all the unique dates in the data set going through the year. Now, really, I don't know that I care about every single day individually. I really just want to know how many infections there were on each day. So I'm going to do what's called a for loop. A for loop in R says, all right, do the same calculation over and over and over and over again. And for loops are really helpful when you're doing data processing because you might want to do the same calculation over and over and over again, but you don't want to type it out every single time. So that's what a for loop does. we have 4, and then in parentheses, t in days. So what does this mean? It says, all right, I'm defining a variable, and I'm just going to call it t. I pick t for time. I want to see every single day in the object called days. Go through all the days, every single one, and perform the same set of calculations on it. That's what these curly brackets are doing. This is saying what code should we run through. And every time we're going to update this value of t for time to be a new day. So what is it going to do? Well, it's going to say, all right, sum is the function here. So we're going to add up all of the days. So in the object called date, or the object called dat, specifically the date, how many of them are equal to t? That's all it's doing. It's counting up how many days there are that were equal to the day that we're looking at, that iteration of the code. And it's going to cycle through how many how many counts there were for each and every day in the data set. The next bit here is looking at for older people. So this part hopefully looks the same. It says sum of dat $date equals t. So add up the number of dates that were equal to the t, the date that we're interested in. But then we have a little ampersand here. And we're going to say, and age greater than 65. So what this is getting at is saying, I'm not just interested in how many COVID infections total there were at any given date. I want to look at how many COVID infections were there for people older than 65. And this will give me information on how, older people who are having infections, because I think that maybe there's a difference between older people and younger people and how they experience the pandemic. This next line here hopefully should look similar. So we've still got this sum of dat $date equals t. So go through and find all the records that had the same date as t, whatever day we're looking at. And we got the ampersand again. This time we're saying dat $age is less than 66. So this is for younger people. How many records were there on a given date for people who are younger than 66? Because I think that that's going to be relevant. Younger people have a different experience in this. And last thing I want to know, just for simplicity's sake, I'd like to know whether or not this was like early in the pandemic or later in the pandemic. So I'm going to say, all right, we're going to have this if-else function. If-else is just a logical thing. So in the if-else function, there's going to be 3 arguments. This is the first one. It's going to give us an if statement. So if time t, the date that we're looking at, is less than, that's what the less than sign is getting at. So the date we have is less than, and I have as date 2020-07-01. So what that's getting at is saying if the date in the data set is earlier than July 1st, then that's the condition I'm looking at. If that has occurred, that the individual date we're looking at is earlier than July 1st, then I want you to store a record of early. In other words, it's early in 2020. And otherwise, we're going to store a value of late. In other words, it's later in 2020. And this will give us a real simple way to split the data between earlier records and later records. There's one way to do this. This is just a simplicity thing. That's what this code is doing. So when we say for with these open and closed parentheses, it's saying go through all of the days in the days object, every single day in the record, and change it from each day for a value of t. And we're going to cycle through each day identified by this value t and run the same calculations over and over and over again. Because I don't want to do that for every single day. That'd take way too long to do by hand. But I can get a pretty good assessment if the computer does it for us. Notice too that each of these are redefining objects. So the idea is to say, all right, I want to create a new object called count, or count older, or count younger, or period. So all of the pieces of information I'm trying to hold on to. I'm going to say, all right, take that value and create it as a new object. and make it be equal to, so the C of statement, that stands for concatenate. It means take something and put them together in an object. So I'm going to say take our current running tally of the count, C of count, so I'm saying concatenate all the counts we have so far, but then add to it the new count. And that's the idea. We're just making a running list. So we're going to take our previous count that we've been doing so far, same object in both places. That's the whole point, trying to say add our previous list to a new value. We're just going to have a running tab here for each one of these objects. The words are the same for each statement because that's what we're trying to do. Take our previous list, add a new entry. That's the idea here. It might take a minute to run just because there's a lot of data in here, but we'll get that running. Really, though, then this will help us summarize our charts because that's what we wanted. We wanted a chart that's going to look at the number of infections over time, and then we want another chart that's looking at number of infections summarizing over time, as well as, between older and younger people. And that's the whole point. When we had, if we scroll up here to the original object, I mean, there's like way too much information. So this is processing the data down so that way we don't have all this information that's like overwhelming to work with. The reality is data processing is a big part of doing research statistics. So I'll set this one up for you to keep it simple, but that's really what comes with this territory oftentimes. If you need help with working through data processing issues like this, talk to us. Go to the office hours consultant. Send me an email. We'll help you. But this is what it takes most of the time. Okay, so we got all of our objects working. So we can look at these. If we want to look at the count variable, this is all the counts, the number of COVID infections for every single day. We've got, how many infections there were for older people on any day, older than 65. How many infections there were for younger people on a given day. And we've also got this period one. This one's going to be obvious. It's early for the first chunk because that's the whole point, prior to July 1st. And then it's late for the second chunk. Now, this is just for us to keep organized. Now that we've got all of our objects set up, I'm going to create a data frame. And that's really just saying I want to put all the objects together so that they're organized in one place. So I'm going to call this chart 1 info because this is the information we need for our first chart. We're going to say chart 1 info is equal to a data frame. So that just means bring them together as one data object. That includes the day and the frequency. And there we have it. Every single day in this first column for days is a new record, a new day, and we have the number of COVID infections reported on that day. This chart 2 info is a little bit more complicated. If we want to look at the counts for older people and younger people, we're going to need to convert this into what's called long format. Because really we have two statistics, but we'd like them to be in one column representing the number of COVID infections. So we're going to use this C of statement. And so we're going to say, all right, give me all the infections for older people for every single day and all the infections for younger people on every day. Put them together in one big long column. And so we're going to create a data frame called chart 2 info. And this data frame is going to have all of our infections in one column. And the variable name is called count. So count equals C of those two groups. In other words, bring together all the counts here. We're going to have another variable in that data frame called period. So it's going to have, really, it's just reiterating the same thing. Is it early or late? But because we have two groups of statistics that are listed out, we're going to need to have period represented twice in here. So it's just going to list out all the same information twice. For group, this is going to represent, is the statistic for older people or younger people? And so we're going to use this rep statement. We're going to say, all right, repeat the section over and over and over again. So repeat the word older for how many iterations? Well, however many records there are in the count variable. So we have 187 records. We want the word older for 187 records because the first 187 records all represent the number of infections for older people. So when we do this, we'll know now all these records are older people. And then we'll do the same thing. This time it's the same length, the same count, the same number of records added, but it's all for younger people. And so if we look at this by selecting rep of younger length of count, it'll give us a bunch of younger over and over again. And that's the whole point. If we look at this CF statement here, so concatenate the two, it's going to help us pick out the first 187 records are the frequencies of COVID infections for older people. And then the second 187 records are the number of infections for younger people. And so if we run all this, we can now look at this chart2 info piece here, this little object, and now we got all we want. It's very long, but here we are. We have the count, so the number of infections, regardless of whether or not it was older people or younger people. We have the time period, so was it early in the pandemic or later in 2020? And then we've got this group variable. So is this statistic representing older people, the first 187 records? Or is it representing younger people? And the reason this is so important is because then we can give this to ggplot and tell it to separate out between different groups of people. So we've processed the data in a way that ggplot will give us the information we want. Last thing here is now I want to make a new variable. So I'm going to go into this object called chart2info. I'm going to do a $sign. So create a new piece of information, a new variable called group period. And that's all it's going to be. I just wanted to take the group we have and the time period and put them together. So that's what this paste statement does. It says paste together, put together the information we have on which group you're in and which time period it was, early or late. And the sep statement just says separate them with a comma and a space. So if we run this paste statement together, here we have older people early, and then older people later in the pandemic, and then younger people early in the pandemic, and younger people later in the pandemic. And that's really the whole point. We've essentially got 4 groups we want to compare based on is it early or late in the pandemic, and is the statistic representing older people or younger people. And if we define this as a new variable called group period, we can just select that chart2info $sign group period and hit run. And it'll show us we've got all that information we need. We can also just look at chart2info as its own object. And it's just got all the information in one place. We've got the statistic, so that's this count variable. And then we've got the period, so is it early or late in the pandemic? Does the statistic represent older people or younger people? And then putting them together for group and period. And that will allow us to make a nice box plot where we have 4 separate groups displayed. That's what we're not going to show here. I'm not going to show you how to work ggplot just yet, because that's what I think you should try to do. See if you can figure it out on your own. At the end, when you finish and submit, I'll send out the code that I did to make it work. So, then you can check your work and see if you're having trouble with it. But I think that'll be a good puzzle to see if you can figure it out first. But that's all the background on all the calculations that were done and why, just so you have context on why all this silly code and, a little bit of background on what it's like working with data. Because oftentimes you do need to do some data processing before you're ready to analyze. All right, that's what I got. Thank you.